Today we're going to talk about lighting in explosive atmospheres. We have done a previous module on explosive atmospheres, hazardous work in hazardous locations, and we've covered that in some detail. Today's presentation ostensibly is more focused on lighting in explosive atmospheres. So let's have a look. Selection of equipment for hazardous locations. Before one considers the selection of different types of protected equipment, we should first look at ways in which the dangers of hazardous locations can be reduced. Wherever possible, electrical equipment should be situated in a safe area, but only where this will lead to a reduction of the hazard. A good example is an electric motor situated in a zone 1 or 2 location, remotely controlled by a starter in a safe location. This is an important point to note for work, whether it's lighting or any type of equipment in a hazardous location. Moving the equipment around so that we don't have the electrical equipment, or we have the minimal amount of electrical equipment in the hazardous location. An example of that second point there, where a motor might be controlled from somewhere else, every single fuel station in New Zealand would have that. We'll have a motor. We have a motor in the pump or in the tank. There'll be some control equipment in there, but the majority of the control equipment, your contactors and all that sort of stuff. And if we think back to something we've done in the last few days, the control circuits, and we talk about on direct online starters, contactors and relays and that sort of stuff. All of that equipment, the contactors, relays, everything like that, in the shop, in the switchboard, so they're not in the hazardous area itself, and that would be fairly common. We'll try and remove as much as much equipment out of the hazardous area as we possibly can. In the case of lighting, however, let's just think about that for a second. Our lighting is, we're probably not going to be able to get it out of the hazardous zone. We might be able to get some of the controls out of the hazardous zone, which is a great idea. But the lights itself, well, if we need light inside the hazardous zone, we can't put the lights anywhere else. That just makes sense, right? And now, before we continue any further, I just want to put some of my own personal spin on this and just clarify in our heads, what are we talking about when we're talking about equipment in hazardous zones, or what sort of equipment should we use? Now, obviously, there's a lot of regulation around, there's a huge amount of regulation around that. Everything that you put in a hazardous area will have some sort of certification on it, and we are required to select the correct equipment for that, with the correct certification for the location we're putting it in. But I just want to clarify what we're trying to do here. What is our goal? And to me, this is not the official thing. This is my own opinion. We have 3 primary concerns with our equipment in a hazardous zone. One is that we do not want flammable vapors, gases, dusts, whatever it is, whatever that hazardous material is, we don't want that entering into our electrical equipment, and in this case, specifically our light fitting. So our fitting should be sealed. In some manner, it should be sealed against the ingress of any of that flammable vapor or gas or whatever it is. Secondly, we don't want any heat or spark getting out of the fitting itself into the area where that hazardous atmosphere may exist. So we don't want our fitting to get too hot on the outside, because just the heat of the fitting itself potentially could ignite that hazardous atmosphere. And we certainly don't want, if there's any arcs or something happening inside that fitting, we can't allow those arcs to get out. So we have to, again, seal our fitting against those 2 potentials and reduce the amount of heat that could be produced by the fitting. Theoretically, reducing the amount of heat on the outside, right? So if there's a way of dissipating it so we're not getting hot spots on the outside, that would be okay. And then the third thing is, in the remote or unlikely possibility that we do have some sort of explosion inside the fitting, that we want to try our best to contain that, so we don't have a massive uncontrolled explosion, which then releases a huge flame, which could potentially ignite a larger hazardous area. So or a larger part of that hazardous atmosphere. So if we do get some sort of gas or something inside it, again in this case our light fitting, we don't want that to be so much, or rather we don't want that any explosion or flame that happens inside that fitting to be able to escape. Generally those are our considerations. So what do we got? We've covered this before. You guys would have seen zone classifications, gases, vapors, and liquids. Remember, we have two classification types. There is one for gases, vapors, and liquids, which is this one here, and there is one for atmospheres that contain dust or potentially explosive dust. So our classification for gases, vapors, and liquids: zone 0 is an area in which an explosive gas atmosphere is present continuously or for long periods. Zone 1 is an area where an explosive gas atmosphere is likely to occur in normal operation. And zone 2 is an area in which an explosive gas atmosphere is not likely to occur in normal operation, and if it occurs, it will only exist for a short time. So if we apply this to fuel stations, and you guys know that is my area of expertise, it's my experience. So whenever we talk about hazardous stuff, I always bring it back there. But we've talked about this before. Our zone 0 is probably inside the pump, and there is generally a sump underneath the pump. So that would be our zone 0. Zone 1 would be the immediate area, say a metre or two around the pump, and at the furthest extent of the hose, that would be a zone 1. And then outside that, the remainder of the forecourt is probably our zone 2. Don't quote me on that exactly, and it'll vary from place to place. But that's a rough idea of what zone 0, zone 1, and zone 2 look like, just so you can put a bit of context on what we're seeing here in front of us. So zone classification for dust is slightly different, as you would remember, I'm sure. 0, 1, and 2 is for vapor and gas. 20, 21, and 22 is for dust, albeit other than this, the different number at the start, each of the dust ones has a 2 in front of it. The 0, 1, and 2 remain the same and has the same definition. So zone 0 for vapor is the same as zone 20 for dust. Zone 21 is the same as 1, so on and so forth. So that's exactly the same as we saw on the previous slide. That's a good one. Okay, equipment rating. This is important to get a handle on what each of these things are. It's not super important to absolutely memorize all of these and be able to recite them. Like, this is not going to be all of the training you get to go and install equipment inside a hazardous area, but I think it's important for us to understand each of these things and know what they mean in general. So if you come across something that's an EXD or an EXS or EXI, you have some awareness of what that is. So start with EXD then, and this is certainly, in my experience in the fuel industry, this is the most common type of flameproof, the most common type of EX, which is our EX being our explosive atmosphere rating. So EXD being our most common explosive atmosphere rating that I've come across. So EXD is flameproof. It's manufactured in such a way that it can withstand an internal ignition. Any gaps or flame paths in the enclosure are designed in such a way to dissipate sufficient energy so that by the time the energy from the ignition arrives and reaches the outside of the enclosure, there is not sufficient energy to ignite the surrounding flammable atmosphere. This means that the equipment needs to be heavy and hence expensive, comprising wide flanges on the mating machine surfaces and deeply threaded entries, providing a labyrinth-like flame trap. Yeah, so as it says on the tin there, flameproof means, as I said a few minutes ago, one of our primary things is if we have an explosion inside of our equipment or a flame inside of our equipment, we need to stop that getting out. And generally the EXD does that by having flame paths. So if you have a box, like it says there, we have wide flanges. So if you have a box, it'll have a thick rim around it where the lid and the box itself meet. And there may actually be a specifically machined gap in there. We're talking about like tiny percentages of a millimeter. and that's designed that if there is an explosion, it's going to be let out, but let out through that flame path. So it will take a long path and it will be extinguished as it gets out. In some situations, in fact, in many situations, we don't want to seal that. Box or fitting completely, because if there is an explosion, then it'll explode. If we have a flame path for it to get out, then the pressure created by the explosion inside, the flame inside, can actually get out in a safe way, so that by the time that flame gets to the outside, it's essentially extinguished. But we're not going to blow the box up by having it completely sealed. EXS, specially protected. So type EXS is designed and manufactured for special requirements and shall be accompanied by a test certificate issued by the SABS to prove it is safe. I've never come across this. It looks to me that this is for a specific scenario, so it would be manufactured for a specific purpose. EXI, intrinsically safe. This is fairly common. I've come across this plenty. The principle of intrinsically safe equipment is both the voltage and current are limited by means of an electronic circuit, so that even under fault conditions, neither the voltage nor the current could ever exceed parameters that would allow an arc or spark large enough to ignite the inflammable atmosphere. So we would use, I've used intrinsically safe equipment in the past on electronic measuring equipment, which I think I've told you about. So what we're talking about there is tank level equipment, that kind of thing. The idea there is that in our intrinsically safe circuit, the amount of energy contained within it is so low that even if you short the two conductors together, you're not going to create a spark. There's just not enough energy there. If we think about it, voltage, the greater the voltage, the bigger the arc, all of that sort of stuff. So we're talking about limiting the energy in a circuit by reducing the voltage, reducing the current, etc., so that there's just no possibility of a spark being created. So it means intrinsically safe means essentially then that no other real protection is really required, right? It doesn't matter. We'll just use it like normal electric stuff. It cannot produce enough of a spark to explode. EXP is pressurized apparatus. This type of apparatus separates the inflammable atmosphere from arcs, sparks, or hot surfaces by pressurizing or purging the enclosures with air or inert gas. The pressure inside the apparatus is kept above the ambient pressure outside. So we have either a sealed or constantly pressurized piece of equipment that's just blowing air or an inert gas, so like nitrogen or something. When we say inert, it can't react with anything else, so it's not flammable, it won't do anything. So nitrogen is the most commonly used inert gas. So it's just pushing positive pressure into that fitting, so that nothing from the outside can come in, right? That makes sense. So no gas or anything like that can come inside our fitting. Just take a quick moment here to tell you that the first two digits for our test are 45. First two digits for the access code for your test is 45. Okay, increased safety apparatus, EXE. This is fairly common, probably after EXD. This is the most common one I've come across. In this type of protected electrical equipment, special precautions have been taken to prevent sparking, arcing, and the occurrence of temperatures high enough to ignite a prescribed gas or vapor to air mixture. A typical type E piece of apparatus for use in a coal mine would have a non-sparking cable terminal connection, be classified IP65, so that's dust type, and be rated to temperature class T1, methane gas. So these ones, EXE is generally used, it's not used like directly in your zone 0, or maybe even in your zone 1. It's just generally a standard type fitting that has been beefed up to make it usable in hazardous atmospheres, but perhaps not in the most serious or dangerous hazardous atmosphere. It's probably the best way to explain it, I think. Non-sparking apparatus. This apparatus is normally used in zone 2 locations where in normal operation It is not capable of igniting a surrounding explosive atmosphere, and a fault capable of causing ignition is not likely to occur. As for increased safety type equipment, non-sparking apparatus is classed with an IP and temperature class rating. So look very, very similar to the EXE, but perhaps a little bit less. Like it says there, are normally used in zone 2. So in normal operation, it's not capable of igniting a surrounding explosive atmosphere. And an important part of this and the EXE one is obviously the IP and temperature class rating. So if we have a suitably IP rated fitting, then it's unlikely that that gases, vapors, dusts, etc. is able to come inside of our equipment, and therefore cannot cause an ignition. And then the temperature class rating means that the actual surface temperature of that fitting would be within a certain prescribed limit, and obviously we would select that temperature class to suit the atmosphere that we're going in, depending on what the explosive, the ignition temperature of our atmosphere is going to be. So the lower the ignition temperature, then the lower the temperature, the maximum temperature of our fitting can be. What else do we have? Dust type and dust ignition proof apparatus. This type of apparatus should be rated at least to a degree of protection 65, IP65. This type of apparatus may be certified for use in atmospheres containing metallic and non-metallic dusts, or non-metallic dusts only, i.e. equipment approved for non-metallic dusts may not be used in atmospheres contaminated with metallic dust. Fair enough. So just a dust proof. This type of apparatus may be certified for use in atmospheres containing metallic or non-metallic. Hazardous area lighting. Hazardous area lighting is ideal for use in areas made hazardous by the abnormal conditions resulting in the presence of flammable vapor or gases and combustible dusts. For hazardous areas, it's important that the lighting product is designed for use in the actual area. All equipment certified for use in hazardous areas must be labelled to show the type and level of protection applied. The lights are classified depending on what type of hazardous areas they are suitable for. The lights are much bulkier and the glass far thicker than the lights we are used to. Right, so all of this stuff here is pretty straightforward and sensible, right? So the equipment will have some sort of label. It's required to have a label to show the type and level of protection applied. So it should say on the EXD, EXE, EXI, whatever it is. And understand that some equipment might have more than one rating on it. It might be EXD flameproof, but also EXP pressurized. We're going to have light fittings that are much bigger and bulkier. Glass is thicker. This is because they need to be protected from the atmosphere that they are in, but also to be protected from, explosions, internal explosions, and that kind of thing. Here are a couple of examples of types of hazardous area lights, and you can see there that we've got a zone rating there. This one can be in zone 1. This one here can be in zone 2. Put my laser pointer on. We've obviously got the normal types of ratings that we have on lamps, like what is the wattage. This one here is specifically for a combustible dust. Although if this is a combustible dust one, then it looks like a bit of an error there, right? Because this is zone 2, but it should be, I guess, zone 22 then. So as we say now, and the fitting itself will have this type of information written on it, so you're then able to interpret what protection levels it has. So competency requirements. Following industry concerns about electrical work and hazardous area installations, government, industry bodies and ITOs decided that specific skills and experience are required by law to carry out this kind of work. Specialist knowledge, skill and experience are needed by electricians working on electrical installations in hazardous areas such as fuel depots, mines, spray booths and laboratories where an explosive atmosphere could be ignited by electrical arc or spark. Electricians should ensure that they have the appropriate training and competency before undertaking hazardous area work, because there is potential for incidents to occur when an installation is not deemed electrically safe. Yeah, so that's an ongoing thing that industry groups are putting their weight behind, various industry groups putting their weight behind that, and there's some debate and disagreement about that. What I can tell you is I do not believe, I could be wrong, but I don't think that there is any specific requirement in terms of skill and experience. You don't have to go and do this course to be able to do this work, for example. However, I think it says that you should be suitably trained or competent, which means that there is a bit of discretion there, but you should be able to prove something. If you have no skill or experience and you screw it up, then they're going to come after you. What you guys need to be aware of is this exists. So you shouldn't be doing hazardous area work. You should not be doing hazardous area work without having some training on that. The risk of explosion or fire must be controlled. In addition, the hazardous area electrical installation must not be connected to supply until it has been inspected by an inspector with hazardous areas experience and has been confirmed to be electrically safe. All work should be confirmed as completed in accordance with the wiring rules and any other applicable standard and regulations. Okay, so again, I'm going to talk about some briefly from my experience about what this means. Any installation that we do, any new work that we do in an electrical installation, and I'll talk about this in the next video. I'll bring up the regs and we'll have a look at that. But it must be inspected. It's high risk work and it must be inspected. So that's any new work. You're installing any new cables, any new fittings, anything like that in a hazardous area. So you're kind of covered there, right? Because you can do whatever you like. I mean, don't push your luck, but in theory you could do whatever you like, and the inspector will come and tell you that's wrong. I mean, you still want to do it right, because otherwise the inspector's going to tell you it's wrong and you have to do it again. But you have that fallback that somebody else is going to come and have a look at it and make sure that you've done it right. However, when you're doing general work like repairs or replacement like for like, so replacing a part with another part, there's no requirement for an inspector to come and do that. So you need to make sure you're doing that right. So my advice on that would be, put everything back exactly how it was. That is your most important thing. Put everything back exactly how it was. So we're talking about, if you open an EXD junction box to work inside it, you need to let's say replace a fuse or change a lead or an electronic board or something like that. All of that work is something that you could do as an electrician, and no inspector is required. It's just normal work. But all of it's happening, so let's say inside an EXD, an explosion-proof junction box, in a fuel pump or wherever. What you need to do is make sure that when you put that back together, you put it back together exactly how it was. An EXD junction box typically will be pretty big, very heavy, and have lots of screws in it. Lots and lots of screws and bolts around the outside of it. That's part of the safety thing, right? Is that it's screwed down 20 screws on the lid. You need to put all those screws back. If you put it back together and miss one of those screws, that is illegal. You have now made that unsafe. It's no longer how it was designed. If there is a rubber seal under that lid, you must put the rubber seal back. If you damage it when you're opening the box or putting it back together, you have to replace it. You must put it back together how it was. That's probably, I think, from my point of view, the most important thing. You could do whatever you like when you pull things apart, put them back together. Do whatever work you want to inside those things, but you must put it back together how it was. And if you're not sure, you need to get in touch with somebody else who does know what they're doing. And then if you do that, then you're going to be pretty safe. You're covered in 99% of situations. All right, let us take a pause there. I will come back to you in the next video, and we will talk about very briefly talk about some specific stuff around regulations. Stay tuned.